Starting with the first property, we're going to be talking about the names of the properties and then give examples using just general variables or algebraic expressions. Then we'll do an example using actual numbers. So some verbal hints to figure out what property we could be talking about. Multiplication distributes across addition. This example is going to obviously be the distributive property. Now the example is saying across addition, so we're going to show this as A times B plus C equals A times B plus A times C. So just as a numerical example, you can see that 3 times 4 plus 5 is the same thing as 3 times 4 plus 4 times 5. The next verbal hint that we have is commute, to get up and move to a new location, to switch places. There are two commutative properties that we're going to talk about. The commutative property of addition and the commutative property of multiplication. The commutative property of addition could be shown by changing the order. A plus B is the same thing as B plus A. And for multiplication, A times B is the same thing as B times A. So we can see that 3 plus 4 is 7, which is the same thing as 4 plus 3, which is 7. And 3 times 4 is 12, which is the same thing as 4 times 3, which is 12. Talking about regrouping elements. When you regroup elements, you're not physically moving them, you're just changing the parentheses. Commutative property changes the order. Associative property changes the grouping. So we're going to use the associative property of addition. And we're also going to talk about the associative property of multiplication. So with addition, if it's A plus, in parentheses, B plus C, this is the same thing as A plus B plus C. For multiplication, A times B times C equals A times B times C. So we can see that 2 plus, in parentheses, 3 plus 4 is the same thing as 2 plus 3 plus 4. Because here we would get 7 plus 2, which is 9, 5 plus 4, which is 9. For multiplication, 2 times 3 times 4 is the same thing as 2 times 3 times 4. So 3 times 4 is 12, times 2 is 24, 2 times 3 is 6, times 4 is 24. Notice that these properties don't work for division or subtraction. Also, a good way to remember commutative and associative would be COAG, C-O-A-G, commutative order, associative grouping. Next would be the identity property, the value that returns the input unchanged. So first let's talk about the additive identity property. So what do you do to a number so that when you add something to it, it's itself? Well, any number a plus 0 will give you itself. For multiplication, it's a little bit different. The multiplicative identity, any number a times 1 is itself. So here we could have 3 plus 0 gives you 3. Here 3 times 1 gives you itself. Next we're going to talk about the value that brings you back to the identity under addition. So brings you back to the identity element under addition. Here we're talking about the additive inverse. Meaning what's going to bring you back to 0. So any number plus its opposite, so if it's positive, then plus its negative, equals 0. This means if you're starting with 3, you can add negative 3, and that'll bring you back to 0. If you're starting with negative 3, its opposite would be positive 3, and that would be its additive inverse. Now for the multiplicative inverse, it's a little bit different. So here, if we started with any number a, and we multiplied it by its reciprocal, you'd get 1. Keep in mind here, a can't equal 0 because you can never have 0 in the denominator. So for example, if I started out with 3 and I multiplied it by 1/3, even if you tried in your calculator, you'd still get 1. If I started off with 1/3, that reciprocal would be positive 3, and that would bring you back to 1. Clue 10 tells you 0 times any value is 0. Here we're just talking about the 0 property of multiplication. So anything times 0 is 0. Just a simple example. 3 times 0 is going to give you 0. Verbal hint for number 11, the sum of any two real numbers is another real number. This is called the closure property. And in this case, we're talking about the sum, so it's of addition. This means that if a is a real number and b is a real number, then the answer is going to be a real number. So if a and b, this means they're both elements, they're in the real numbers, that means that c also has to be an element of the real numbers. So for example, 10 plus 5, 10 is a real number, 5 is a real number, the answer 15 is a real number. Number 12 is similar. The product of any two real numbers is another real number. So here this is just the closure property of multiplication. So if a is a real number and b is a real number, then the result c will be a real number. So if a and b are real numbers, they're elements of the real numbers, that means c will be an element of the real numbers. So for example, 10 is real, times 5, which is real, So the product 50 will also be real. The next hint says adding the same value to both sides of an equation will not change the truth value of the equation. So we're going to see this a lot. Let's say you have x equal to 10. That means that if you add 3 to both sides, they're still going to be equal to each other. So x plus 3 is still going to be equal to 10 plus 3. This is called the addition property of equality. And all this means is that if A is equal to B, then A plus C is equal to B plus C.